Hello everyone and welcome to iLAN Technologies presentation on securing the LAN with Draitec VigaSwitches. Today we'll continue with the second part of this webinar series. As mentioned in our previous webinar, local area network security is now a major consideration when designing data networks, and we'll be looking at how to improve security on the LAN by utilising the features available in Draitec Layer 2 and Layer 2 Plus VigaSwitches. My name is Darren and I'm the Queensland Sales Rep at Draitec Australia and New Zealand. We'll start by looking at IP conflict prevention and how it can improve network stability when rogue devices are connected to the network. We'll also look at how access control can be used, as well as some other features such as port security, storm control, denial of service attack prevention, loop protection, and block ports recovery. Stay tuned at the end because we'll be online for 5 minutes afterwards to answer any questions. Don't forget you can pause the video or skip back anytime if you'd like a longer look at anything or to hear it again. Okay, let's start by looking at IP conflict prevention. In part 1 of this webinar series, we looked at client authentication using IP SourceGuard and client isolation using DHCP snooping and dynamic ARP inspection. Draitec have now combined these two methods into a new feature called IP conflict prevention to make it easier to set up and administer. So why do we need IP conflict prevention? Well, if you've ever had a network outage due to someone plugging a new device into the network with the same IP address as the server or router, you'll understand how frustrating it is to track it down and remove it from the network. That may have been an honest error by the person who did it, or it could be someone intentionally trying to get around the security measures. The solution here is to use the IP conflict prevention system available in VigaSwitches running the latest firmware versions. This system will monitor the network environment and notify the network administrator of any IP conflicts, as well as block the rogue or misconfigured devices. The VigaSwitch will take a snapshot of the network design so it's aware of where the servers, router and access points are connected, as well as which ports are used for computer connections. With this information, the VigaSwitch can make smart decisions on the fly to identify potential issues before they cause disruption to the network or network resources. Once a misconfigured or malicious device is detected, it's blocked immediately. In the example shown here, we have a device on Gigabit Ethernet port 2 using the same IP address as the DHCP server on port 8. In this case, port 2 will be blocked, preventing disruption to the DHCP server. In this table, we have some examples of what can cause network disruptions due to misconfigured devices on the network. A DHCP conflict will cause invalid IP addresses to be issued or even cause the valid DHCP server to go offline. IP conflict prevention will also work when there's multiple edge switches on the network which don't support IP conflict prevention. The edge switch can be any other brand. In this case, the core Draitec switch will handle the IP conflicts. In the example shown here, PC4 on the edge switch conflicts with PC1 on the core switch. PC4 is blocked from the core switch, but PC4 still can access other hosts within the edge switch. When an IP conflict occurs, the status will be shown on the switch GUI so that the network administrator can quickly identify where the problem is. As mentioned earlier, IP conflict prevention is based on 3 features, which are DHCP snooping, which is used to protect the DHCP server and clients, IP SourceGuard to block users not on your list, and dynamic ARP inspection to prevent ARP spoofing. IP conflict detection is enabled by default, so no configuration is needed in the VigaSwitch. Alerts are displayed on the web interface of the switch, but can be sent via email if required. To set up IP conflict prevention, the 4-step wizard in the VigaSwitch can be used. Here we need to specify the DHCP server, confirm all the port types, then confirm which hosts you want to protect, and finally select Enable. The DHCP server is usually the uplink port of the switch if the router is used as a DHCP server. Once selected, it will block illegal DHCP servers on the network. The next step is to select the port types, which can be any one of those shown here. The third step is to confirm the protected hosts. Here you can manually enter the IP address connected to a particular switch port. It's a good idea to include the PC that will be used to manage the network here to prevent from being locked out. The final step in the configuration is to enable IP conflict protection. Once an IP conflict is detected, the conflict source will be displayed in the dashboard page of the VigaSwitch. Mail alert can also be configured to notify the network administrator. I'll now go through the configuration process using the 4-step wizard, then test when we introduce a device with a duplicate IP address. To configure IP conflict prevention, we need to log into the VigaSwitch, then under the security menu, go to IP conflict prevention. Then click on the IP conflict prevention tab on the page. Here we have the Quick Start Wizard button at the top. Clicking on this wizard, we can see that there are 4 steps. The first step is to specify the DHCP server, which in our example is on port 1. Click on Next to go to step 2, where we need to confirm the port types. Port 1 is the DHCP server and port 12 is the DHCP client. We can click on the port to change the port type. All the green ports are DHCP clients. Ports 17 and 18 is multiple hosts, so we can click on the ports to change them to blue. Now click on Next to go to the next step. In the third step, we have to confirm the protected hosts. Here we also check that your admin PC is also included in the protected hosts table. The IP address of my PC is 192.168.27.11 and is not included in the protected hosts table at the moment, so we'll need to add it. The PC is on port 12 and it is a DHCP client. We enter the PC IP address and click Next to continue. The final step is to enable IP conflict prevention. The IP conflict protection will now start working and display any conflicts on the dashboard. Okay, let's create an IP conflict now and see what happens. We'll change the WAN IP of the Viga 2860 to be 192.168.27.14 so that it conflicts with the access point on port 18. If we now have a look at the switch dashboard now, we can see that there's a conflict on port 18 and it's caused by a device on port 17. So we now have 2 devices with the same IP address. Let's try to connect to 27.14. Okay, that worked for the access point, and the reason it did is because the access point has the valid IP address, so the 2860 has been blocked. Now that we've looked at IP conflict prevention, let's look at access control. This is where we define which destination a client can have access to. It will be like a layer 2 firewall for your local network. So why do we need a layer 2 firewall when we already have a layer 3 firewall in the router? The reason is that the layer 3 firewall cannot control layer 2 traffic since it's in the same subnet and will not go through the gateway. The access control list is an allowed list oriented firewall. By default, all traffic is denied. The network administrator can create a set of rules to permit or deny traffic or shut down a port. There are 3 types of access control lists. These are MAC access control list, which filters layer 2 non-IP traffic. There's also IPv4 and IPv6 access control lists, which control traffic based on the source and destination IP addresses. This can also limit certain IPv4 and IPv6 protocols, such as TCP, UDP, IGMP, ICMP, and others. This is where we create the rules for access control based on MAC addresses. We need to specify the sequence number for the rule as they're run in sequential order starting from the lowest to the highest number. For each rule, we specify the source and destination MAC addresses, ether type, VLAN, and QoS. In the example shown here at the bottom, we have 2 rules, with rule 2 being the last rule to block all. Here we have the IPv4 access control configuration page in the switch. As mentioned earlier, it's used to filter traffic to or from a host or a group of hosts or entire subnets. We need to specify a sequence number, select the IP protocol, source and destination IP addresses, source and destination ports. After we create the access control lists and rules, we can apply them to each port on the switch. In the example here, Gigabit Ethernet port 4 has both MAC ACL and IPv4 ACL. The order in which these ACLs are applied is MAC followed by IPv4, then IPv6. Let's check out a demonstration where we block the PC on port 12 from accessing the Viga AP903 access point on port 17. To configure the access control list, we go to the ACL menu. Here's a MAC ACL profile prepared earlier called Block AP. We also have an IPv4 profile called Block Angela. The next step is to create the rules. For this, we go to ACE menu, which is short for Access Control Entry. For the MAC control list, we select the rule we want to edit. We'll add rules to the access control list called Block AP. Here we specify the sequence number and the required action, which can be permit, deny, or shut down. So here we have the rule which says to block the PC MAC address to the MAC address of the AP903. The next rule is to permit any to allow access for other devices. Now we apply this setting to the switch port, which is port 12. So now if we try to ping the access point, we can see we get timeout since the PC is blocked. If the rule is removed, we can see that we can now ping the access point. Now let's test IPv4 access control, which will use the IP addresses of the devices. First, we go to the IPv4 tab, enter the source IP address that will be blocked from accessing the destination IP. We need to go to ACL binding menu, specify port 12, and select Block Angela for IPv4 ACL. Testing using ping shows timeout, so it is blocked. I'll now go through some additional security features that can be used if you want to strengthen your network. The features that can be used are port security, storm control, DOS attacks, loop protection, and blocked ports recovery. If you have a situation where anyone can walk into a conference room and plug in their own device, they may have access to company resources, so port security will be important here. One way to do this is to limit the number of clients connected on a switch port. Preventing users from connecting their own switches and access points to the company network will reduce the possibility of MAC table flooding attacks. MAC table flooding can occur from sniffing attacks where the attacker sends more MAC addresses than the switch can handle, or can fill the MAC address table with fake MAC addresses. This will cause valid traffic to be slowed down since the switch needs to relearn the valid MAC addresses. Also, an attacker can eavesdrop multicast packets. The other type of attack is denial of service attack, where continuous MAC flooding, similar to a sniffing attack, which again will overload the switch resources, reducing its ability to handle other tasks. On the right, we have a screenshot of the port security menu options. Port security is a per port setting where the port can take the required action when the specified number of connected MAC addresses is exceeded. The action can be to forward or discard the data packets, or to shut down the port when the number of connected MAC addresses is exceeded. The MAC addresses are first come, first learned. Static MAC addresses configured in the switch LAN MAC address table are unaffected by the port security settings. Let's now check out a demonstration of port security. On port 19 of the VIGA switch will allow a maximum of 1 MAC address, and on port 20 will allow a maximum of 2 MAC addresses. So on port 19, if someone connects an access point or a switch, it will prevent additional devices from accessing the network. Port 20 will allow one other device to be connected to the attached switch. We'll need to count all the MAC addresses connected to port 20, so we need to count the MAC addresses of the attached switch as well as any other devices connected to this switch. We'll start by going to the web user interface to configure port security. Go to the security menu and select the port security submenu. Enable ports 19 and 20. Port 19 we set 1 MAC address, and port 20 we set to a maximum of 2 MAC addresses. For the action, we select shut down the port when the number of connected MAC addresses is exceeded. So here we have the final setting. So now we'll connect a device to port 19. On the dashboard, we can see that port 19 is online and it's now locked when the number of MAC addresses is exceeded. Now we'll connect this device to port 20. Port 20 is online, so let's connect another device to port 20. And we find out it now causes port 20 to be locked since the maximum number is exceeded. Okay, moving on to storm control. When storm control is enabled, the VigaSwitch will continuously monitor the selected switch ports for unicast, broadcast or multicast traffic storms. When a traffic storm is detected, you can either drop the packets or shut down the ports. This will prevent the LAN from being degraded. Here we have a screenshot of the storm control port settings. You can set a threshold for each type of traffic to trigger the required action. The traffic type includes broadcast, unknown multicast and unknown unicast. The action can be either drop the packets or shut down the port. Next we have DOS protection to prevent DOS attacks. Denial of service is a type of attack that will shut down the network, making it inaccessible to its intended clients. This is usually done by flooding attacks, sending malicious packets that trigger crashes. On the right we have the traffic types that can be monitored to block denial of service attacks. To enable this function, we go to Security and the Denial of Service menu. Click on Properties. By default, all these properties are enabled. However, we have to go to the port settings and select the required ports and then enable DOS protection for them, since DOS protection is disabled for all ports by default. Dratec VigaSwitches also provide loop protection to automatically shut down the port when a loop is detected. Looping can occur when connecting two switches with 2 ports on each or connecting 2 ports on a single switch. It consumes switch resources, reducing network performance. It can cause a broadcast storm or denial of service. When a loop occurs, data packets start cycling in an ever-increasing loop until infrastructure devices eventually become overwhelmed and stop responding. By default, every port is enabled for loop protection, but it is disabled in the global setting. Let's have a quick look at how loop protection works. On the VigaSwitch, we'll loop ports 38 and 40. When the ports are blocked, we can see the lock icon on the ports. The syslog will also display this information. To enable loop protection, we go to the Security and then the Loop Protection menu. By default, the status is disabled, so we have to enable it. Once we do this, the state changes to enabled and the action is to shut down the port once a loop is detected. Okay, so let's create the loop between ports 38 and 40. And we can now see that port 40 has been blocked. To unblock the port, we can click on the lock icon on the port and the port will be recovered. We can also set up blocked port recovery, which will recover the port automatically after the preset time interval. This is where we configure blocked ports recovery. We enter the time interval before the port is restored and also which block conditions to recover from. Okay, that's the end of our presentation today. To summarise, we looked at how IP conflict prevention works and how it can improve network stability when rogue devices are connected to the network. We also looked at how access control can be used to define where a client can connect to, as well as some other features such as port security, storm control, denial of service attacks, loop protection, and block ports recovery. Okay, once again, that's it for me, but please stay tuned. Staff will be online answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about Dratec products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or just give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification of new premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thanks and bye for now.